Hello, fam. This is Zekaya from Mathatainment, reminding you that enthusiasm implies excellence. The lesson we are going to look at today is under algebra. In particular, we'll be factorizing quadratic expressions. Before we do that, I would like to define what a quadratic expression is. Well, we define a quadratic expression as an expression whose highest power of the unknown variable is 2. Once you see that the highest power of the unknown variable is 2, then you know that you have a quadratic expression. For instance, look at this general expression that I gave you there. The expression is ax squared plus bx plus c. The unknown variable there is x, and the highest power of x is 2. So this confirms that you have a quadratic expression there. Well, now let me define what we call a quadratic binomial. From a quadratic expression, some of them, they do have special names. They are those with 2 terms. We call those ones a quadratic binomial. We call those ones a quadratic binomial. There's nothing special about it. It's only that the value of b is 0. So it means you only have the coefficient of x squared, and the coefficient of x is actually 0, and then you have a constant. For example, here is one example. Here we have 2x squared minus 4. This is an example of a binomial. It's a quadratic binomial because still the highest power of x is 2. And then you have what you call a quadratic trinomial. That's when you have 3 terms in your quadratic expression. Still, the highest power of x there is 2, but you have 3 terms, so you have a quadratic trinomial. How to factorize this? Well, I'm going to plug you guys with 2 methods of factorizing this. The one is what you do when you find a common factor, and the other one involves what you call a trial and error method. Factorizing on its own is when you are converting your expression from having more than one term and you want it to have a single term. When you write your expression in a factorized form, then it only has one term. So, from the examples that you saw above, when you want to use a common factor, to employ a common factor, that is usually compatible with a quadratic binomial. When you have 2 terms, it's advisable that you employ a common factor. And whenever you take out a common factor, please don't forget to divide each term with your common factor in order for you to know what remains inside the bracket. So we're going to look at the first example that we saw above there, which is 2x squared minus 4. So let me write that one. I have 2x squared minus 4. Can you see that you have 2 terms there? Because terms in an expression are separated by either a plus or a minus. So there you have 2 terms. You want that thing to be a single term, or you want to have one term. To do that, you can recognize that if you take out 2 as a common factor there, what remains inside the bracket, that's when you divide each term of your expression with the common factor that you took out. In this case, it is 2. Minus 4 over 2. So what you have now, you have 2, and then inside the bracket, 2x squared over 2, that is exactly x squared, minus 4 over 2, that is exactly 2. So you can see that here you are left with 2 into x squared minus 2, and that expression entirely is now a single term. It's a single term because it's just the product of 2 factors. One factor is 2, another factor is x squared minus 2. They are multiplying each other. Hence, you have a single term. And that's when you have a binomial. But when you have a trinomial, we are going to do what we call a trial and error method. When you have a binomial, it's advisable to do what you call a trial and error method. The word is self-explanatory. Trial means you are trying. An error means there is a possibility for you to fail, so you will have to try using another approach. It's called trial and error method. It's like when you are, as you are going to see when you are applying to study at universities, you will apply at one university, maybe you won't qualify there, but it doesn't mean that's the end of the road. You may apply at another university, maybe you will be admitted there. So it's called a trial and error method. It all depends on your results anyway. So let us look at this in terms of a quadratic trinomial. The example that we saw for a quadratic trinomial is x squared minus x minus 6. I'm going to highlight this example for you there. You saw x squared minus x minus 6. So I will come down here and write that example as it is. You have x squared minus x minus 6. That's what we have. What it means to take it to do a trial and error method. So look at this. In general, a quadratic expression looks like this. We have ax squared plus bx plus c. So what you need here, you need two factors of a. And I'm going to write this in blue. And you also need two factors of c. What do you want to do with this? You want to multiply the factors of a with the factors of c such that when you add or subtract that product, you get b, which is the middle term. That's something that we want to do, but at this point, it's a little bit abstract, but you will see what we are going to do here. Look at this. Our trial and error method goes like this. For this one, the coefficient of x squared there, that is a, it's 1. So the factors of 1 are easy. That is 1 and 1. And you see how I write them vertically. I'm doing that for a purpose. And now, there are various factors of 6. I can write 6 as 2 times 3. I can write 6 as 1 times 6. So to start with, let me try 1 times 6. 1 times 6. Now, I'm writing those factors vertically again on the right-hand side of the factors of 1. Now, look at what we do here. We say 1 multiplied by 1. And what we are getting there, we are getting 1. And then we say 1 multiplied by 6. And what we are getting there, we are getting 6. So now, this sign here, the sign that I'm highlighting there, that sign says I must subtract the product of these and see if I get the middle term. 1 minus 6, I don't even care about the sign, but that drops down to 5. Even though it's negative 5, but I know that drops down to 5. However, I don't see 5 in the middle term. It looks like my attempt didn't succeed in that regard, but that doesn't mean it's the end of the road. I can try other factors of 6. For instance, let me try now. So it's a trial and error method. Okay, let me try now 2 and 3 instead of 1 and 6. Let's try 2 and 3 instead of 1 and 6. 2 and 3. There, here we go. 1 times 2, it becomes 2. 1 times 3, it becomes 3. And then that sign means we have to subtract. 2 minus 3, it drops down to 1. Aha! And exactly the meekly term there, it has 1. It doesn't matter that it's -1, but the fact that it has 1, then I know that I'm on point. So now I want to collect my factors. This is how you collect your factors. Your factors then therefore goes like this. It's about time you collect your factors. They go like this. 1 goes with 2 as I'm circling them like that, and 1 goes with 3 as I'm circling them like that. So when you come there to write, we are going to have the factors on your left hand side. You suffix them with your unknown variable. In this case, the unknown variable is x. So it means instead of 1, I'm going to write x. X goes with 2. I open another bracket. X goes with 3. And then, now the question that I'm going to ask myself now is, you see the sign that I highlighted there? That's highlighted in green. I will highlight it again so that you will see. I'm highlighting this sign again. That sign, since it's negative, it says your signs there between your factors must be different. They shouldn't be the same. One should be minus and one should be plus. Your signs are different. And then now that you know that your signs are different, you shift slightly and now see this highlighted part there. I want to change the color of my highlighter for that one. You see this one now. The one that I'm highlighting in pink. That sign tells you that the bigger number deserves that sign that I highlighted in pink. Now that you know that the signs are different, then the bigger number deserves the sign that I highlighted in pink. And the sign that I highlighted in pink is minus. So the bigger number there is actually the 3. So 3 deserves a minus. Therefore, the 2 becomes a plus. That's how we factorize that. So that is fully factorized. So now that expression entirely is now a single term because it's a product of two factors. One factor is x plus 2, another factor is x minus 3. That's how we use the trial and error method. So now let's just look at a couple of examples regarding what I just told you guys. Now, here we are required to factorize this. The first example is 3x squared minus 4x. The first question you should ask yourself, how many terms are there? 3x squared minus 4x, I have 2 terms. So that is what we call a binomial. That is what we call, it's a binomial. It's a quadratic binomial. Since it's a binomial, then we know that we want to employ a common factor there. We want to employ a common factor. So a common factor there, you can take out your x as your common factor. What remains inside, remember you divide each term of your expression with your common factor, which is x in this case. That's why I'm having 3x squared all over x minus 4x all over x inside the bracket. Therefore, I have x into 3x squared over x, that is the same as 3x, minus 4x over x, that is the same as 4. Now I have my single term. That expression there is fully factorized. It's one term now. One factor is x, another factor is 3x minus 4. You have a single term in that regard. Let's look at the second one. The second one is 3x squared minus 27. How many terms are there? I bet you know how many terms are there. There are 2 terms again, and you still have what we call a binomial. Hence, we are going to employ the common factor again. Well, the common factor there, if you take out 3 as the common factor, what remains inside the bracket, remember you divide each term of your expression with the common factor that you took out. In this case, that is 3. So that's why I'm having 3x squared all over 3 minus 27 all over 3. That's what I have. So now I have 3 into 3x squared over 3. I'm left with x squared minus 27 over 3. That is exactly 9. Well, I'm going to hide now that's already a single term. It's already a single term. One factor is 3, another factor is x squared minus 9. So that is already a single term. However, it looks like we can go further with the second factor there, which is x squared minus 5. It sounds like something that we have heard about before. 9 is a perfect square because the square root of 9 is 3. X squared is also a perfect square because the square root of x squared is x. And the sign between those terms, you have a minus there. So you have x squared minus 9. And the minus means the difference. So this is the difference of two squares, which we may have heard about it before. When you have an expression of this form, x squared minus y squared, which is the difference of two squares, we factorize this like this. We have x minus y and x plus y. So in this case here, I can write 3, and instead of x squared minus 9, we write x minus 3 times x plus 3. That is how we factorize x squared minus 9 because it is the difference of two squares. Now that is fully factorized, and still that is a single term. It has 3 factors now. The first factor is 3, the second factor is x minus 3, the third factor is x plus 3. Please notice that when you factorize quadratic expressions, your factors are actually linear factors. I repeat, when you factorize quadratic expressions, your factors are actually linear factors, meaning the highest power of the unknown variables in your factors is 1. For this case, the unknown variable is x. So in your factors, the highest power of x is 1. So your factors are in the form of linear expressions. Okay. Now, let us move on to another example. We are also required to factorize x squared plus 2x minus 8. The first question that you should ask yourself here is, how many terms are here? There are 3 terms. Since there are 3 terms, it means you have a trinomial. You have a trinomial there, and you are required to employ what you call a trial and error method. Well, the coefficient of x squared is 1, and you have 2 factors for 1. It's just 1 and 1. I'm writing them vertically like that. And then your constant, which is c, is 8. 8 has a number of factors. One is, you can write 1 and 8, and it also has 2 and 4. Let's probably try 1 and 8 and see what we get. 1 times 1, I have 1. 1 times 8, I have 8. And the sign that I'm highlighting there says I need to subtract those two products and see if I get the middle term. It looks like what I'm getting drops down to 7. It's not what I see in the middle term. I need to change my combination then. Instead of 1 and 8, I'm going to try 2 and 4. Those are still factors of 8. 1 times 2, I'm getting 2. 1 times 4, I'm getting 4. And when I subtract those 2, it drops down to 2. Hence, my factors are as follows. This is how I collect my factors. 1 goes with 2, and 1 goes with 4. Remember, the factors on your left-hand side, you suffix them with x. So here, I have x going with 2, and I have x going with 4. And the sign highlighted in green says your factors must have different signs. they must have different signs. And then once you know that they have different sign, then the sign that I'm highlighting in pink now says the bigger number deserves that sign highlighted in pink, and 4 is the bigger number, so 4 deserves that plus, hence 2 deserves a minus. Fully factorized. It's a trinomial. Now it's a single term. Let's move forward and do the last one. Factorize 5x squared minus 13x minus 6. That's still a trinomial. It is a trinomial, so you want to employ your trial and error method. 5, I have two factors for 5. It's just 5 and 1. And then for 6, I can do 2 and 3. Let's see if I'm getting the correct Mickley term. 1 times 2 is 2. 5 times 3 is 15. And the sign that I'm highlighting in green says that I need to subtract those products. And when I subtract them, it drops down to 13, which is precisely the Mickley term. So now I'm going to collect my factors. Let me collect my factors. 5 goes with 2 and 1 goes with 3. Now, this means that what you shouldn't forget is that the factors on your left-hand side, you suffix them with x. So I have 5x going with 2, and then I have x going with 3. That's what I have. Now, the sign highlighted in green says that the sign between your factors are different. Now that you know that they are different, then the sign that I'm highlighting in pink says that the bigger number deserves that sign. What we are comparing here, you are comparing 3 and 2 over 5. Not just 2, but 2 over 5. Why 2 over 5? You imagine this if it was an equality. If it was an equality, you would get x equal to 2 over 5. You would get x equal to 2 over 5, whatever the sign is, but you would get x being equal to 2 over 5, whether positive or negative, but it would be 2 over 5. That's why we are comparing 3 and 2 over 5. And it turns out that 3 is bigger than 2 over 5, hence 3 deserves the negative. 3 deserves the negative. Then the 2 over 5, or the 1 next to 2, deserves the positive. Now, this is fully factorized. So, guys, this is how to factorize quadratic expressions using either a common factor or using the trial and error method to find the factorized version of quadratic expressions. I'm not leaving you guys alone because I'm very fond of you. I'm leaving you with your problems to try. This is yours to try. You want to factorize the following expressions. The first one is x squared plus 6x. We have two terms there. I bet you know what you want to employ. The second one is 4x squared minus 16. You have two terms there. I also think you know what you want, what you are going to employ there. The third one is k squared minus 2k minus 3. That's a trinomial. The fourth one is 3k squared minus 13k minus 10. That's also a trinomial. So please try those and see if you understood today's lesson. Thank you, guys. I'm going to meet you again on the next lesson. And the next lesson will be on actually solving quadratic equations now. Now that we know how to factorize quadratic expressions, we're in the right position to solve quadratic equations. Just stay tuned. You are on Metattainment. We'll meet again on the next lesson. Thank you.